the properties tend to decrease. It's not true. Because here you mostly have metals here. On this other side you have non-metals, fluorine and chlorine. Now, elements in the same group have the same number of electron shell. That is not correct because we say elements in the same period have the same number of valence shell. So this cannot be correct. It cannot have the same number. It's actually period I have. Now this one, elements in the same period have the same number of valence electrons. This is wrong because it's only elements in the same group that has the same number of valence electrons. But you see this V, the valence electrons of the elements in the same period increase progressively. That is true. The valence electron for sodium is 1, magnesium is 2. So as it is going here, is increasing. Aluminium is 3. You understand? The same thing here. Lithium, the valence electron here is 1. That of beryllium is 2. Boron is 3. Carbon is 4. So the valence electron is actually increasing progressively across the period. That makes option B the right option. Time to draw this, so take note of this. The periodic table for the first 20 elements. The periodic table is actually the arrangement of elements according to the atomic numbers. You can see we have 7 periods and 8 groups. Elements in the same group have the same number of valence electrons, whereas elements in the same period have the same number of valence shell. And non-metallic properties tend to increase from left to right of the table, as well as the number of valence electrons also increases from left to right across the period. Thank you. Yes, let's look at these JAMB past question chemistry 2018, question number 8. The boiling of fats and aqueous caustic soda is referred to as A. Hydrolysis, B. Esterification, C. Acidification, D. Saponification. Now, if you look at these options, you see that basically we know the meaning of hydrolysis, which is when you want to get something with water. Esterification, the reaction of ethanol with acid to form esters. Acidification, getting something with an acid. Then saponification is the hydrolysis of fats and oil with caustic alkali to yield propane 1,2,3 triol, and the corresponding sodium and potassium salts of the component fatty acids. And these salts are actually the principal constituents of soap. So saponification is the process of producing soap by hydrolyzing it with fats, by hydrolyzing the fats with caustic soda. So the process here is actually saponification when you look at these definitions. So I'm going to state the definition of saponification. Saponification, very, very importantly, is the hydrolysis. You can see this topic in organic chemistry too. Hydrolysis of fats and oils with caustic alkali. You can see this in the definition given of the making saponification the right answer. Hydrolysis of fats and oil with caustic alkali, yielding or producing propane 1, 2, 3. Propane 1, 2, 3 triol, and the corresponding sodium and potassium salts of the component fatty acids. So saponification is actually used in soap production. So the salts of these sodium and potassium, they are actually the major components of the soap. So we use saponification for soap production. So in saponification, what happens is actually have your fat or oil. In this case, we are using fat. So fat or oil plus caustic acid alkali. In this case, we are using caustic soda, aqueous caustic soda. So if you have these two combined, you're going to have soap. And you know that soap is actually the sodium and potassium salts as a soap. Then what else do we have? We now have what we call propane. 1, 2, 3 triol. So that's how you produce your soap. That's how soap is produced. So this is the process of soap creation, saponification. That makes the right answer to this, saponification. Thank you. Now let's look at this question number 9 for JAMB past question chemistry 2018. Which of the following pairs of substances will react further with oxygen to form a higher oxide? A. CO2 and H2O. B. NO and H2O. C. CO and CO2. D. SO2 and NO. So which of the following pair of substances will react further with oxygen to form a higher oxide? Now, what are higher oxides? If you want to understand this, we need to know what higher oxide are. What are higher oxides? Higher oxides are compounds with greater proportion of oxygen. So any compound in which there is greater proportion of oxygen. Like now you have H2O, which is a normal neutral oxide. Now you have also H2O2, which is hydrogen peroxide. This is a peroxide. So this is a peroxide, specifically this is hydrogen peroxide. So this is a higher oxide because there is more oxygen here. This O2, this is normal O. So this is a neutral oxide. You should know that we have neutral oxide, we have higher oxide, we have basic oxide, we have acidic oxide, the ones that are from non-metals, basic, the ones that are from metals. These ones, they are from non-metals, and they also form acidic solutions. These ones from basic solutions. These oxides, there are also what we call amphoteric oxide. We need to know about this as well. These amphoteric, they can behave as acidic oxide, we are trying to learn. Neutral oxide, like H2O. But we also have hydrogen peroxides, and we have also other higher oxides. In fact, now what we can go. But here in this question, they are asking us which of these pair now will oxides like this peroxide, whenever you have something like this, there is disproportionate number of oxygen. Oxygen is in higher proportion. So how do you get about this? So you can see that you can actually get about this by having more oxidation of the normal oxide. When you oxidize them, when they have more oxygen, they have higher oxides. So which are the oxidation agents here that can help you to have such greater amounts of oxygen? If you look at this, you see that you have CO2 is an oxidizing agent and O2. So this can do it. This does not have enough oxygen in it. This does not have. This actually reduces. It can reduce oxygen, the CO2, the CO. Like the CO when you inhale it, it can reduce the oxygen in your body. And this also has lesser, though this one has plenty oxygen. So you can say that this is an oxide. This is also a good oxide. So these two can actually oxidize something that has normal oxygen into higher oxide. So I think option A is a suitable answer for this. D would have been because of SO2. Consider NO. So that is why I picked this option A. Thank you. Now let's look at this question number 10 for WIEC past question chemistry JAMB 2018. In the preparation of oxygen by heating KClO3 in the presence of MnO2, that's manganese oxide, only moderate heat is needed because the catalyst acts by A. Lowering the pressure of the reaction, B. Increasing the surface area of the reaction, C. Increasing the rate of reaction, D. Lowering the energy barrier of the reaction. So what happens with the catalyst? When you add a catalyst to a reaction, what happens is majorly one thing, to lower the energy barrier of the reaction. That's what happens. So this is a direct answer. D is the answer to this problem. Because what actually happens whenever there is a catalyst added to a specific reaction is that the energy barrier is lower. So you have a reaction, a normal reaction that would have gone like this. So you now have it to go like this. So the energy barrier is reduced. This height is reduced to this height. So that's what happens. That is the effect of catalyst. Whenever you add a catalyst to a reaction, it reduces the energy barrier, making it so that you don't have to suffer so much to get to the next level. You don't have to suffer so much to move from the reactant side to the product side. So that energy that you need to have in order to make this passage from reactant to product is reduced. So that is why you add a catalyst to reduce the energy barrier. So it's none of this. It cannot be to reduce the pressure. Catalyst does not go to affect the pressure or the surface area of the reaction, but it does reduce the energy barrier so that with lesser energy you can achieve what you want. Thank you. Now let's look at this question number 11 for JAMB past question chemistry 2018. Methanoic acid mixes with water in all proportions and has about the same boiling point as water. Which of the following methods would you adopt to obtain pure water from a mixture of sand, water, and methanoic acid? A. Fractional distillation. B. Filtration followed by distillation. C. Neutralization with sodium hydroxide followed by distillation. D. Neutralization with sodium hydroxide followed by filtration. Now, whenever you see a separation process in which the constituents have the same boiling point, the most ideal method for separation is fractional distillation. Very, very important. So this alone makes this the right answer. Whenever they have very similar boiling point, that is what you use. Like where we have crude oil. In Nigeria, crude oil is our major source of income. So to separate crude oil into kerosene, normal fuel, the BMS, AGO, diesel, and the rest of them, you use a process known as fractional distillation. Why do we use fractional distillation to do this? Because they have close boiling point. They have close boiling point. They have similar boiling points. So that's why you do that. And in this case, you're having something that's having the same boiling point. So you need about the same. Not actually the same, about the same. It's hard for you to have two substances of the same boiling. So if they are about the same, that means they have close boiling point. Then the best option is fractional distillation. Filtration followed by distillation. You can filter out sand, but you cannot use ordinary distillation to separate water and methanoic acid because of their similar boiling points. Neutralization does not have anything to do with it. It's why you neutralize it with sodium hydroxide, so it makes this not to be the answer. Neutralization is followed by filtration, and it's not also a very good answer. So the right option is fractional distillation because they have about the same boiling point. So fractional distillation is what you use. Or if you're separating a solid from liquid, you can easily use, if you're separating a solid from liquid, you can also use filtration for this. But fractional distillation does it because at the right temperature, what is going to happen is that the one with lesser boiling point will go out first. Let's say if it is either methanoic acid or water, it goes out first. Then the next one, which is water, goes out. If it is having lesser boiling point, then you have your sand remaining. So you have these two components go out, then you have your sand remaining. So when the first one goes out, it is collected. The second one going out, it is collected differently too. Then you have your sand left. So the best way is to use fractional distillation. Hello, welcome. Let's look at this question number 12 for JAMB Past Question Chemistry 2018. A quantity of electricity liberates 3.6 grams of silver from its salt. What mass of aluminium will be liberated from its salt by the same quantity of electricity, given that aluminium is equal to 27 and silver is equal to 1.8. Option A, 2.7 gram. B, 1.2 gram. C, 0.9 gram. D, 0.3 gram. Now, whenever you want to solve the problem of electricity and the position of metals, first of all, you need to know the number of valence electron, or the number of electron needed for such action to occur. So let's say for silver, what we have for silver, silver is plus. So we're going to have one electron because it's just one valence.
Doing something with other things.
make S gram the subject of ammonium cross multiply, you're going to have that. You're going to have X gram to be equal to 0.033 times 27 all over 3. That's when you cross multiply. You have 0.033 times 27 all over 3. So if you do this calculation, what are you going to get? You press the calculator. If you press your calculator, you say 0.033 times 27, which is going to give us 0.891 divided by 3. It will now give us 0.297. So if you make this calculation, 0.033 times 27 all over 3, what are you going to get? You're going to get 0.297. So this is the mass that will be operated, 0.297. And this 0.297 is approximately equal to 0.3, because this is 9, so we can approximate this to 0.3 gram. So the right option is going to be D, 0.3 gram. So note the way we calculate this number of moles of electrons needed to liberate this. You already know by checking the valence electrons. So it actually gives what you have here, the number of moles you have from the normal equation gives you the amount here for the atomic mass. So that is how you go about solving this. So take note of this and do the appropriate substitutions, and you get the correct answer. Thank you. Yes, let's look at this question number 13 for JAMB Past Question Chemistry 2018. Suitable reagents for the laboratory preparation of nitrogen are A. Sodium dioxynitrate 3 and ammonium chloride. B. Sodium trioxynitrate 5 and ammonium chloride. C. Sodium chloride and ammonium trioxynitrate 5. D. Sodium chloride and ammonium dioxynitrate 3. So what is the correct answer? Now, if you check the textbook, chemistry textbook for under nitrogen and its compounds, note that the laboratory preparation of nitrogen is actually from, there is laboratory preparation of nitrogen from ammonium dioxynitrate 3. So how do we come about this? So like I said, this is the lab preparation for nitrogen. Laboratory preparation for nitrogen from ammonium dioxynitrate 3. But how does this happen? This actually happens by using a mixture of sodium dioxynitrate 3 and ammonium chloride. And this mixture is actually done in the ratio of 7 is to 5. And this mixture is done when it is heated to yield. Whenever you heat, when you heat this mixture, you will now yield ammonium dioxynitrate 3. This ammonium dioxynitrate 3 produce nitrogen and steam. So you see the way nitrogen is produced from ammonium dioxynitrate 3. But how does this ammonium dioxynitrate 3 come to be? By having a mixture of sodium dioxynitrate 3 and ammonium chloride. That's how you produce this. So once you have a mixture of sodium dioxynitrate 3 and ammonium chloride, produce ammonium dioxynitrate 3, which can easily decompose on the heating to produce nitrogen. So you can see here we have sodium dioxynitrate 3 and ammonium chloride. That makes option A the right answer. Because the mixture of sodium dioxynitrate 3 and ammonium chloride, the ratio of 7 is to 5 produces ammonium dioxynitrate 3, which decomposes
Young man.
on heating, and which decomposes to give nitrogen and steam. So that is the preparation of nitrogen. And you can find this on the this. So that's what happens in terms of equation. You actually have it as sodium dioxynitrate 3, which is actually aqueous, reacting with ammonium chloride, which is also aqueous, to form ammonium dioxynitrate 3, which is aqueous, and sodium chloride, which is also aqueous. So this very ammonium dioxynitrate 3 is ammonium dioxynitrate 3, which is aqueous, then further decomposes to nitrogen, which is what you're looking for, gas plus the steam through H2, which is liquid. So that's how you get about the laboratory preparation of nitrogen. Thank you. Now let's look at this question number 14 from WIEC Chemistry JAMB Past Question 2018. The number of electrons in the valence shell of an element of atomic number 14 is A1, B2, C3, D4. Now, you have to know how to draw the electron shells for the electronic configurations of elements given their atomic number. So now you're given the atomic number of 14 and you're told to draw in order for you to find the number of valence shell electrons. So you have to have the first electron shell, which normally had just 2 electrons. Then subsequent electron shells have 8. So you now have to count out the number of atomic numbers in the atomic number. So you have 14. So you have 1, 2. This one should have 8. So you have 1, 2, 3, 4, 5, 6, 7, 8. 8 has completed it. But is it up to the number of atomic number here? Yeah, it's 14. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's still 10. Many life. So we have to have another electron shell, but this time around it will not be up to 8 because what is remaining is just 4. So we have 1, 2, 3, 4. So if you count the total number of electrons, it should be equal to the atomic number. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12,
But I even started
14. So we have 14.
So my university, do you see that?
So it's not equal to this. But note that the inner shell must have only 2 other other shell, other electron shell,
You know why?
will have
It was my brother,
8, 8.
my other brother.
So the valence shell
took
is
me
the
to
last shell. So
Okay,
this is the last shell.
And what we did that day,
So
I
this
was
has
convinced
completed
because of
the
him.
normal
It's
atomic
the reason
number,
I
which is 14.
I
So
was even
how
able
many
to eat it
electrons
that day. And because of that, it
are
was the only
on
thing
this
that I
valence
could
shell?
buy
We have
outside.
only 1,
I
2,
couldn't taste
3,
the
4. So that makes
and was
4
happy.
the answer.
But not very
So let's say this has an atomic number of 13.
by
What would have been here? Would have been 3.
No. Most times I
Had
consider
12,
how the
would have
environment.
been here, would have been 2.
Sometimes I
Had
feel
11,
like
would have been
they
1.
may not have
Had 10,
hygienically.
would have been 8. Because of
But
this,
sometimes I may be hungry now.
valence electron would have been
I
gone.
may want to buy food
So
now.
remaining this
I go into the farm, you know,
negative
there's
10, 1,
just
2,
one
3,
single
4, 5, 6, 7, 8, 8. So the valence electron would have been 8. So but for 14 it is 4. Even it's 15, would have added extra 1 there, making it 5.
But no, at the top of the
It
town,
is 16,
although
would have been
I do like I stay conscious of the environment. Once I come out, I set the
it's 18
person
would have been 8, but if it is 19, would have added another shell.
If the person is near this year,
So the valence would have been just 1.
I can't believe it.
So take note of this. The right hand side is 4, 14. Thank you.
Don't finish. Cut fish now.
Hello, welcome. Let's look at this question number 15 for JAMB Past Question Chemistry 2018. What volume of oxygen will remain after reacting 8 cm cubed of hydrogen gas with 20 cm cube of oxygen gas? Is it A 10 cm cube, B 12 cm cube, C 14 cm cube, D 16 cm cube? The statement is 3 is actually superscript. All the 3's on the same cubes are superscripts. Now, how do we solve this? This is a very simple one to solve because first of all, we need to write the equation of this very reaction of oxygen and hydrogen. So if you have hydrogen, which is H2 gas, reacting with oxygen, which is O2 gas, we know you are going to have H2O, which is water. Now, how do you balance this? We have 2 hydrogen here, 2 hydrogen here, 2 O2. So how do we make this O2 2? We are going to put 2 in front here. But now the edge is now 4, so we have to put 2 here. So you can see the ratio here, 2 is to 1. Then on this other side we also have 2. So now, anytime you're having 2 of hydrogen, you have 1 of oxygen. Therefore, if you have 8 cm cube, 8 of oxygen, you're supposed to actually have 4 of oxygen. Because this one is half of hydrogen is always oxygen. So when it was 2, this is 1. So when it's 8, this should be 4. But in this time around, they are saying if you react this 8 with oxygen, which is supposed to take on 4. But here we're having oxygen 20. So how many will be remaining? So it's going to be 20 minus this 4 that is already taken on to give us 16 cm cubed. So the answer is D, 16 cm cubed. So very simple, you have to write the equation. You have to deduce what your answer is from the equation. Thank you.
Yes.